Ladies and gentlemen, good day to everyone, and welcome to this tutorial on complex numbers. We are going to answer those pertinent questions that have been coming over the years in the topic complex numbers. So trust me, before the end of this tutorial today, we shall move from being a beginner in complex number to become an expert in complex numbers. So just click on subscribe to this YouTube channel for more video notification. Begin with question number 1. A. We're going to start with A. We are given two complex numbers, Z1 and Z2. And now we are asked to express Z1 and Z2 in the form R cos theta plus I sin theta. We're going to start with Z1. Expressing Z1 in the form, we know that Z1 is equal to 1 plus I root 3. Now we have to express in the form R cos theta plus I sin theta. Now we are trying to express this in the form R cos theta plus I sin theta. Now what is R? We need to know that R is the modulus of the complex number. So R1 for Z1 is the modulus of Z1. Now how do we find the modulus of the complex number? The modulus of the complex number is gotten by taking the square root of the real part of the complex number squared plus the imaginary part of the complex number squared. We have a complex number of this form. The real part is this one, and the imaginary part is the one attached to I. So this is the same as the square root of what? 4, which is 2. We now have to find theta. But now what is theta? Theta is the argument of the complex number Z. So theta 1 for Z1 with the modulus of the complex number Z1. Now, but Z1 is equal to 1 plus I root 3. If we plot this on the Argand diagram, like this, on the Argand diagram, this will be plotted in the first quadrant because the real part and the imaginary part are all positive. So it's going to be plotted in the real, in the first quadrant. And in the first quadrant argument or theta, because the theta is just equal to the tan inverse of y on x. What is y? The imaginary part, and x, the real part. So root 3 over 1 is the same as root 3. But now, means theta is equal to the tan inverse of root 3 is pi on 3. So we are done for that. Now I can express Z1 in this form. So I'm going to have R, which is 2 cos theta pi on 3 plus I sin theta pi on 3. That's done for Z1. And I'm going to do the same thing for Z2. We have that Z2 is equal to negative 1 minus I. So we are also going to express this in the form R cos theta plus I sin theta, where R is the modulus. R, which is now R2, is the modulus of Z2. So R2 is going to be equal to what? The square root of negative 1 squared plus negative 1 squared. Exactly. So we're going to have the square root of 2 as the modulus of Z2, which is R. Now what about theta 2? Is the argument. Is the argument of Z2. Now if we plot Z2 on the Argand diagram, we have negative real, negative imaginary. So it's going to fall in the third quadrant. Now if it falls in the third quadrant, it means we are going to have that theta 2 is equal to, now it's going to be equal to, it's going to be equal to the tan inverse of y on x then plus pi. Generally, if we want to find the argument of any complex number, provided that complex number can be plotted in the first quadrant, then theta is simply the tan inverse of y on x, no matter the sign. Now, in the second quadrant, theta is equal to pi minus the tan inverse. In the third quadrant, theta is equal to pi plus the tan inverse. And in the fourth quadrant, theta is equal to negative tan inverse of y on x. So this is the general way of finding the argument of a complex number. I'm going to drop such a video to this channel. So when we do that to this, we are going to have tan inverse of 1 plus pi. Tan inverse of 1 is pi on 4 plus pi. This is going to give us 5 pi on 4. So we have that theta 2 is equal to the tan inverse of y on x. So 1 on 1, which is 1. And so theta 2, which is the argument of z2, is equal to pi on 4. Pi on 4. So now, expressing it in this form, we're going to have that z2 is equal to r, which is root 2, cos of pi on 4 plus I sine pi on 4. This is it for z2, and that is it for the A part of the question. Now we go to B. We go to B. We have to start by looking for z1 over z2 ordered group. This is the same as the modulus of z1 cubed over the modulus of z2 cubed. Now the modulus of z1 was 2. So we have 2 cubed divided by the modulus of z2 was root 2. So we have root 2 cubed. If we continue, we are going to have this as 8 divided by 2 cubed is 8 divided by 2 root 2. 2 root 2. So we are going to have that is the same as 8 over 2 root 2, which is the same. 2 can cancel. So we are left with 4 over root 2. But we never leave a rational function in the denominator, so we can rationalize by multiplying top and bottom by root 2. And finally we are left with 2 root 2. That is it. Secondly, we have to find the argument of z1 over z2 ordered cubed. Now, property of argument. This is the same as 3 times the argument of z1 over z2. It's still the same as 3 times the argument of z1 minus argument of z1 minus the argument of z2. Yes, so it's the same now as 3 times. Now, the argument of z1 was pi on 3, and the argument of z2 was pi on 4. So this is same as 3 times pi on 12. So we have it as 3 pi on 12, which is the same as pi on 4. So this is it for the question on complex numbers that came in June 2023. Paper 2, question 3. Thank you for watching and see you in the next video. Please subscribe.